Hey guys, I hope you're doing really well this week. This is my project for this weekend. So this is a 32-inch TV. It's a Samsung. It's quite an old one, but I got this with a batch of 4 TVs, and unfortunately all of the rest of them have cracked screens, so this is the only one that I've an opportunity to fix. What's happening with this, it's actually plugged in behind, but there is no standby light. When I press the power button, you can hear it there, nothing happens at all. So we have no power coming to this at all. So what I'm going to do is I'm going to take the board out, I'm going to take some images of it, and we're going to have a look and see if we can get it fixed. This is the picture that I've taken of the power board. Now, just a quick disclaimer before we go any further. This is a walkthrough of what I have done with this power board, but I am not recommending that anybody follow any of the steps that I take here. This is purely for demonstration purposes only. And with that said, we will continue on to the next section. So this is our power board. Now simply what this does is, if you break it down, just to try and break it down into blocks is sometimes easier to do with these, because as you can see there's quite a lot of components in it. But very simply, this accepts 230 AC from the mains in here because we're in Ireland, and the output is different lower DC voltages, one of which is a 5.3 volt standby voltage. As I said, and as you could see yourself from the screen, we're not getting any standby voltage. So this could be an issue with this board, or it could be an issue with one of the boards further down the line that LED is connected to. However, it's probably more likely that it is something to do with this board. So what I'm going to do first is have a look around this and see if I can spot anything immediately indicating that there is a fault. I don't see anything straight away, but if we look, there are certain components that are under quite a bit of pressure and fail regularly on these switch mode power supplies. For example, like the bridge rectifier, the fuse, of course. Sometimes these filter capacitors can fail. You may see another video on the channel where a filter capacitor failed. These MOSFETs are under quite a bit of stress. They can fail as well. But I'm not seeing anything here. These secondary filter capacitors can also fail, but these usually show bulging on the top when they're failed, whereas as you can see, these ones look brand new. The diodes, the secondary diodes can also fail. I think these are the diode packages here to rectify AC back to DC. They look fine as well. Although with diodes you won't usually tell unless they're completely blown up. This just shows you how old the TV is. These are inverters to convert DC to high voltage AC again to power LCD bulbs. Nothing wrong with these either. Okay, so from the top it doesn't look like there's anything wrong with this board. Let's take a look at the other side. And this is the back of our power board. So can you see anything there that doesn't look good? The image, the board actually came out quite dusty on this for some reason. But is there anything that you can see across there? I think I actually scanned this in too high resolution, because you can see right in. See how close I can zoom in on this? But when you zoom out, it's like there's too much detail. But as you look across the board, is there anything that doesn't look right there? Because it's pretty obvious on this. Okay. Have you spotted it yet? I don't know whether we should play that game where I take 4 stills again. But no, the part of it that looks damaged, you should be able to see it quite clearly, is this part right here. So this is the bridge rectifier. I can recognize it immediately because it's really the only chip on the board where it has 4 large pins in a row, and it's close to the input section. So the idea with this is that we have our live, our neutral and our earth pins from our 3-pin plug. They go through a small filtering circuit here. It's all AC at this point, and then at this point it hits our bridge rectifier, which is a set of 4 diodes to convert the high voltage AC into DC. Now this can fail, and as you can see right here, it looks like something has blown up here. So what I'm going to do is I'm going to take that out of circuit and see if it is in fact blown. Just before I desolder the bridge rectifier, I'm just going to take you along the path that the live and the neutral take as they make their way through to the bridge rectifier. So we have our live right here, and the live connects to Okay, I'm going to draw this in on the fly. Let's see how I can do this. So we've got our fuse right here. So we come across the fuse, then it comes down here across this inductor, and then up to what looks like another inductor here, and it makes its way onto one of the pins of the bridge rectifier. And that's the path that it takes. So across this fuse, across an inductor here, across a second inductor and a third inductor, and it makes its way to the middle pin of the bridge rectifier. Following the path that our neutral takes, well, our neutral wire comes in here. Let's move that up to 100 pixels as well. Okay, it comes across here through this inductor, up here, here, and onto the other center pin of our bridge rectifier. So some of you might be asking, why have I bothered to draw these out? I can obviously see there's an issue with the bridge rectifier, so why not go there? Well, what I want to do first is just to make sure that there's no issue with the path to the center pins of the bridge rectifier. And how I do that generally is, I don't like working on these with the AC connected. You can certainly check for 230 AC on these middle pins, but I don't like checking it with the power on. So what I would do is I would disconnect the power completely, discharge the main filter capacitor, and simply carry out a continuity test between this pin, which is one of the pins of our C13 connection, our power cable coming into the TV, and this pin here. And when I checked this, there was continuity between these. So it looks like the bridge rectifier may be blown, but it didn't take out the fuse. I also checked for continuity between my neutral pin here and the other center pin of the bridge rectifier, and this is continuous. I also checked again to make sure that there's no short between the two of these, and there's no short between the two of these. So it looks like our input section up to the bridge rectifier is good. We're going to now take out the bridge rectifier and see if that is our only fault. This is our bridge rectifier out of circuit. So I'm just going to show you the checks that I carry out using diode mode on the digital multimeter. So on this digital multimeter, it's marked as a diode like this. So I place my red probe to the first of the center pins and my black probe to the positive, and when I did that I got 0.480, which is okay. That should be measuring one diode. When I placed my probe to the second of the pins and measured, I also got 0.480. So that's measuring okay. To test the other two diodes in that package, I placed my red probe to the negative pin, and I placed my black probe again to the first of the AC pins, and I measured 0.480. I then placed my black probe to the second pin, and I also measured 0.480. So it seems like the four diodes in this package are actually good. So given that our bridge rectifier appears to be okay, I'm curious as to what is going on, because the fuse is not blown. We do have marks of damage here. This is obviously the picture before I removed the bridge rectifier, but when you look at that pin, it doesn't seem like it's making a connection. But it's not just a cold joint, because there's signs of some sort of spark there. So I'm not sure what's going on. Now I checked these two pins with my multimeter just to see if there was a short on the DC voltage side, and there's no short there either. Now what I'm going to try next is I'm going to just replace the bridge rectifier anyway. Even though the one is testing good, I'm just going to replace it with another one from another TV, because these are pretty common. And I'm going to chance powering it on and see what happens. And I'm going to take a video to see if it explodes. Okay, so I have replaced the bridge rectifier and I have soldered over that joint properly, and I'm going to try plugging it in now. So let's try and plug it in and stand back just a little bit. Okay, we have audio there, no backlight so far. Okay, so it looks like it's working. Not sure what that buzzing noise is all about, but maybe it just makes that noise when there's no signal. But that looks like our TV is up and running. So what was it? The bridge rectifier was checking good. So I think it was just that bad joint on it. But what caused the bad joint? Who knows? That's the video for this week, guys. I know you guys aren't really interested in TVs. I just don't have any interest in laptop stuff this week. Like I said before, just having difficulty getting laptops, so I just wanted to throw something up. But hopefully we'll have something a little more interesting next week. Talk to you soon.